is just to see what you guys already know, and what you guys learned a little bit from the last lesson that Ms. Amador gave, and also just to see what you guys need to work on. So you guys can start now. And then once you're done, just set your pencil down, that way I know. We just have a few more people in. Okay, so you guys are going to pair up and just kind of converse about what you guys got for your answers. Think about why you got your answers, and when you, on number 5 and number 6, when you explain, talk to each other and figure out why you think this and why you thought that thermal equilibrium was, and things like that. So pair up in partners, and you guys can start talking about it. Compare answers.
Wait, I don't know. This is why I want to get this. Okay, so the air, like, there's not, like, hard to learn. I don't know.
I feel like German has reaching equal amounts.
Okay, I feel like it's when there's an equal amount of pieces.
Oh, yes.
I don't know.
That makes sense. That's right. Same. That's good.
You transfer it, you flow, and
Okay, so did everybody talk to each other? Yeah. Okay, so we're going to go over the answers. So for number 1, it's D. Did everyone get that right? Yes? Okay. Number 2 is A. You got that one wrong. Okay. We'll go over that more in detail in the PowerPoint. Number 3 is C. Did everyone get that right, or anyone get that wrong?
I got that.
4, what do you guys think number 4 is?
True.
True, right. Okay, so number 5, I want to hear some of your guys' thoughts about this one, so anybody want to volunteer to say what they put?
thermal equilibrium is when either temperature of a substance is the same throughout, or multiple substances reach the same temperature.
Right, yes, good job. Did everyone have something around there? What did you put?
We pump like when the temperature has reached like an equal amount.
That is true, yeah. The thermal equilibrium is where it occurs when two bodies have the same temperature, the heat flow goes through each body and kind of makes it the same temperature. And we'll discuss that more also in the PowerPoint. Okay, so number 6. Does anybody want to think about number 6 was? William? No? It's okay, even if it's wrong, it's just a pretest.
Heat transfer is when heat, which is a high energy, flows to a lower energy, which is a colder area.
That's right. Higher temperature to lower temperature. Good job. See, you don't have to be doubting yourself. So yeah, thermal energy flows from higher temperature to lower temperature. That's also heat transfer. So did everyone think they did pretty good on this, or? No.
No, we got 1 right.
No, that's okay. That's why we're going to go into more detail about this. You guys can pass them to like one end of the table and I'll come around and pick them up. Okay, so everyone get paper out because you guys are going to be taking notes during this PowerPoint. Have a piece of paper out. Ready to go. Okay, so we're doing 11.2 in the learning goals. Compare and contrast various methods of heat transfer, which you guys just did in the second. You will learn the differentiation between thermal conductors and thermal insulators. And you guys will explain what it means when objects are in thermal equilibrium. And all these are going to be tests just to see what you guys know. So through this lesson, these are what your learning goals will be. And then so this is what you guys will be doing in a few days. Okay, so first off, thermal energy flows from higher temperature to lower temperature, and that process is called heat transfer. And there are 3 ways the heat flows. There's heat convection, conduction, and also thermal radiation. Make sure you guys know what these 3 are, and then we'll go into more detail about them. Because you guys, at the end of this lesson, you guys will also have a short quiz. If I go outside and I sit on the cement on a hot day, it's gonna be hot against my bottom. So that is like conduction right there, from solid to solid, touching particles of matter, touching and touching. The heat.
Cube in the sand when it's really hot, so it just melts.
So thermal equilibrium. Make sure you guys know this part. Thermal equilibrium occurs when 2 bodies have the same temperature. So right here it shows you have one, you do solution of water. One is 100 degrees Celsius and the other is 50 degrees Celsius. When you pour that 50 degrees Celsius into the 100 degrees or the 100 degrees into the 50 degrees, they're going to try to measure each other out. So right here it shows how we went from 100 and then 50 to 75 and 75. That's just an example of thermal equilibrium. So no heat flows in thermal equilibrium because the temperature is the same in 2 materials. So if you put hot tea in a freezer, you keep the tea in the freezer until it meets the same temperature as the freezer, which makes it just like ice. If you put ice in the freezer, it's going to become a solid because the temperature in the freezer is way colder than what the water is. And also right now in my chemistry class for college, this is exactly learning about as well. But so far, does everyone understand what I'm talking about? Does anybody have any questions? No? Okay. So, thermal conductors and insulators. Materials that conduct heat easily are called thermal conductors. So, sometimes a lot of like metals are considered conductors. And then those that conduct heat poorly are called insulators. So, like I guess a jacket would keep the heat in, and it doesn't let other heat or coldness come in as well. I'll let you guys get this real quick. Talk about more thermal conductors and insulators, like examples of them. Does everyone have this down here? See 4 more minutes? So here's just some examples. You have, like you said, copper, so it's aluminum, gold. A lot of, not all metals are conductors, but most of them are. So thermal insulators, wood, styrofoam, plastic. Make sure you just write some examples down on your papers. Because on the quiz you might have to state what some examples are. Also put some of your own ideas in there. Alright, next we have convection. So convection is the transfer of heat through motion of matter such as air and water. And when it says motion, it could also mean the flow. So the flow through air and water. So right here on this diagram, the hot water at the bottom of the pot rises to the top and replaces the cold. Now we're going to do an activity.
Look at
Okay,
me.
so for this
Does it look
activity,
like I
you
can
guys
see?
can get in groups and discuss it and go over it. Oh yeah, you guys can start. If you guys have any questions, let me know.
Wait till Gabby gets back, okay? Sorry.
And there is a front and a back.
I don't know, is my timer going off?
Transfer.
12? Oh, plenty of time. Perfect. So, what would that be? Convection.
What is this? I thought there was convection.
They are touching it.
They are? Oh, so when you push it down, they...
They squeeze. That would be what?
I don't want to spread.
What'd you put? Yeah.
Okay, that one is...
Read your directions. Sometimes it's two things. Remember what your directions say. Okay. But, I mean, it depends on where you're saying you're getting your heat from. You're getting your heat from up here above the fire or over here. If you're getting it up here, it's convection. If you're getting it over here, it's radiation. Well, we'll talk about it. We'll talk about it. Yeah, we'll talk about it. We'll talk about it with them when we do the discussion. How far are they to finishing? Oh, and there's a backside too. We'll probably have to discuss it tomorrow, huh?
Yeah.
Yeah.
Never mind, I have some. Because by heating it up and the thingy, use the flow of heat, not the direct.
Sometimes.
Same.
By heat makes it better.
Yes.
So, she told us that there wasn't many, there was like none that had multiple.
There's only one that had two.
Yeah.
That's what she said.
I think there's more. Because, we were just discussing this.
It's like, that would be convection and conduction.
Well-
'Cause even if you don't touch it, it's hot.
Yeah. Tomorrow. You just let it go. I'll get it. Just, you go ahead and talk.
Okay, so you guys can start packing up because the bell's about to ring. We'll finish this up tomorrow. So keep it with you. And remember to